All right, guys, welcome back. We are looking at chapter 5 with Professor Ren, and we were discussing, this is video 2, we were discussing elasticity of demand, and now we're going to look at, how do we actually calculate it. Now, we calculate the elasticity of demand and elasticity of supply using the mid-range method. Now, what does that mean, the mid-range method? It means we find the halfway point between the initial change in the price and the final change. Same thing with the price, with the quantity demanded, and use that instead. So let's look and see, and then I'll show you why we do that, but let me just give you an example. What is the elasticity of demand if due to an increase in price from $13.10 to $13.90, quantity demanded changes, drops from 410 units to 400. Okay, we're going to do this in 3 steps. You don't have to do it in 3 steps. You can just divide a fraction by a fraction. That's perfectly fine. But I'm going to show it to you in 3 steps because it's simpler for most people, and this is what more people are comfortable with. But as you know how it works in math, there's more than one way to arrive to the same answer. So if you have a way that makes you feel better about it, that's fine. Percentage change in quantity demanded is 10 units, right, divided by 405. Why is it 405? Because what's the halfway point between 410 and 400? So if you were to add up 400 plus 410, you get 810. And you divide that by 2, you end up with 405. So if you're not sure how to do this, just remember you add up these 2 points where the value was to begin with, where it ended up, and you divide by 2. And that is in your outline for chapter 5 that I left for you. So there are definitely a lot more details in there. So take a look. This is just an overview that we're doing. So 10 divided by 405, that's going to give you 0.0246. You multiply that by 100, you get 2.46 because we're working with percentiles. So what's the percentage change in the Y, which is the quantity demanded? 2.46. What's the percentage change in price? The percentage change in price, Okay, had a technical problem right there. Somehow I ended up deleting this this page. Okay, let's look at this here. Not to be too click happy in the meantime. Okay, so the percentage change in price. So what happened to the price? The price rose from 310 to 390. That's an 80 cents differentiation. This is where that 0.8 is coming from. And what's the halfway point between 1390 and 1310? It is 13.5, meaning if you add up 1310 plus 1390 divided by 2, you're going to get 13.5. Well, this is going to give us a price change of 5.9%. You get a decimal, you multiply it by 100 to get your percentage. This is your percentage right here. Now, right off the bat, you see something. Just pause for a second. What changed by a greater percentage? The price. This is advantageous to a business. This means the consumer really, really likes this product. The consumer is either stuck with this product somehow, like they really need it, or they love it somehow. So the elasticity of demand, which is taking that percentage change in quantity demanded, dividing it by the price over here. By the way, if for whatever reason you can't remember which goes on top, remember this expression, price is the bottom line. Price is the bottom line, price goes on the bottom. So the quantity change is 2.46, the price change is 5.9. This gives us an elasticity of 0.41. This is inelastic demand. And because demand is inelastic, it means the consumer is not flexible in their purchases. They're stuck on this product, they're willing to pay the higher prices. Either, as I said, they have real strong brand loyalty, or they're like stuck somehow because it's very difficult for them to go get it from anywhere else. And so they're subject to the price increase and there's nothing they can do about it. But this is basically what we are looking at as far as how we use the mid-range point. You're adding the initial price to the final price and you're finding the halfway point. You're taking the initial quantity and the final quantity and you're finding the halfway point. The way you do it is you add them up and divide by 2. Now I want to show you why we do it, the logic behind it, okay? The logic behind it is because of how percentages work. So let's look over here. Look with me on the left side of the screen. If price drops from $100 to $80, what's the percentage change in price, right? It's 20%. How do we know that? Because we started with what price? 100. So if you take the difference between the 120 and the 80 is $20. This is where we are. We take the difference. 20 divided by the original price of 100 gives you a 20% change. So on the down from 100 to 80, the percentage is 20%. On the up, it is not 20%. If prices rise from $80 to 100, what's the percentage change in price? Well, it's still $20 because that's the difference between where the price was and where it is. That's the 20. Or that divided by the original, divided by 80, gives us 25% change in price. So you see what's happening here? Because on the down, the price change is 20%, on the up is 25%, what we prefer is 22.5. So if we were applying the mid-range point, we would not use either one. We would say, let's use 22.5. That way, whether the price goes up or down, we're coming up with a final answer that's closer to the reality of how things are. This is why we use it. Now, as far as the types, there are 5 types of elasticity of demand. It can be inelastic, perfectly inelastic, elastic, perfectly elastic, or unitary elastic, also known as, like equals 1, when it equals 1. Okay, so let's look at them here a little bit. Unit or unitary, depending on who's writing it. So perfectly inelastic demand is, actually I'm going to start us right here. Let's look at elastic demand. This is more like what you're used to seeing from a demand curve, right? Now, why is this elastic? Let's look at the point differentials here. The price goes from price 1 to price 2, right? So you take 2 points on a curve, and in this case, make them a little bit farther apart like this, and that helps you see a little bit. The price drops by, visually you can confirm, by a lot less than the quantity change. So this is a curve that's almost horizontal. It's leaning horizontal, right? So it's going to be elastic. Quantity demanded, in this case, changes by too big of a percentage against the price as a percentage. This gives us elastic demand. Now, elastic demand is very common. So if we were to say what is the most common type of elasticity of demand, it would be elastic demand, which means the consumer is price sensitive and the consumer is going to look for a cheaper alternative when necessary. This over here is the opposite. This is inelastic demand. If you take 2 points here, look at these 2 points. Look at how much the price changes by. You can confirm this visually. And look at how little the quantity changes by. This is something like tickets to a concert you really want to go to, and even though the price started at 100 and now it's 300, people still are buying seats to go because they just really want to go to that concert. They care more about the fun at the concert and the quality of the singing and performance than they do about the price. So they're not very price sensitive. In this case, there's definitely staunch brand loyalty. Now, unit elastic, if you see what it's doing, unit elastic, the same exact change in the price happens in the quantity. It's not going to be too common, but where you find it is with things like utilities. This can be the case. So it's a proportional change from price as a percentage to the quantity as a percentage. Now the other two, here's perfectly elastic demand. Perfectly elastic demand, the price is not going to change, though the quantity will. So this is something like perhaps oil prices. Oil prices are set by the market. I'm talking about crude oil here. So let's take like the North Sea Brent crude oil. It has a market price. So whether the price, let's say the price is $110. Well, at $110, whether you sell one barrel or you sell 1,000 barrels or 1,000,000 barrels, it's all at the same price. So it's going to be horizontal. If you remember from graphing, when you see a horizontal curve, you're looking at the price, which is in this case, what's right here on the Y, is independent of what's happening down there. So the price can just flatline and the quantity will keep rising anyway, depending on how much is being bought at that price. So the quantity can indefinitely grow, but the price doesn't change. Now, do you see what I mean about how you know this is elastic? Because elastic is moving towards horizontal. So when you're judging a curve, just ask yourself, is this curve look more horizontal? That means it's still in the elastic range, or does it look more vertical? Like if you look at this one, just straighten it up a little, you see where it's going. It's going towards a vertical state. Now, what does it mean when it's vertical? It means the quantity is independent from the price. It's the opposite here. The quantity doesn't change even though the price really, really is. So if you go back to that example I was telling you about a concert, it may very well be actually perfectly inelastic demand. This can actually be surgery, where the price of surgery keeps rising, but the number of surgeries that needs to be performed doesn't. Because there is naturally X number of people who require it, and even though it's expensive from year to year and ever more expensive, the number of people who require it is pretty much the same. And the surgery is just going to be like, let's say that they perform at the hospital 3 surgeries of this kind a day. The price for the surgery keeps rising, but the number of surgeries is 3. And it's right here stuck at 3, and it doesn't actually change. So those are the 5 types of elasticity. The most common are these two, elastic and inelastic, with the absolute most common of them all is elastic demand. The more a demand curve turns horizontal, the more elastic it is. The more it turns vertical, the less elastic it is. This is what you are actually dealing with. So to recap a little bit, this is elasticity of demand that equals 0. This is elasticity of demand that is less than 1. This is elasticity of demand that equals 1. This one is elasticity of demand that equals infinity. And this one is elasticity of demand that exceeds 1. Equals 0. Less than 0. It's a decimal, but not 0. Equals 1 exactly. And this is all using the mid-range point that we used before. And you have a bunch of examples in your outline. You have it in your homework, and you have it in the exercise that you're going to be handing in. You're going to be uploading. And then this one, it equals infinity, and this one is more than 1. This is what you're looking at as far as elasticities. So for more details, just refer to all the notes that you actually have. We're going to stop right here for now. We're going to come back and look at the revenues and what happens based on the elasticity. I'll see you in video 3.